All right, so this is just a little bit of a review sheet, I guess. It's 2 pages. The first page has 20 questions. The second page has 37 questions. Well, altogether 17 questions. So I'm going to go over this stuff with you guys now so that you kind of have not just an answer key, but you have an explanation to accompany your answer key. But don't think that watching this is the best form of studying. You should have tried it on your own. You should be pausing it periodically to try things and check and make corrections without just watching me do them. Okay, so in the beginning we are practicing for a test. The unit was called polynomials and polynomial functions. So polynomials in general, as well as functions, meaning we evaluate them for a certain input, we get a certain output. We get only one output for each input. We can graph them and they'll pass the vertical line test. We can find x-intercepts, we can find y-intercepts. Using a calculator, we found the maximums and minimums, so on and so forth. So for the beginning here, write each polynomial in standard form. Do you know standard form? Standard form is descending exponential order. So your biggest power should be in front, to the left, and it should sort of trickle down and descend. And we should also combine any like terms. All right, so write each polynomial in standard form. That's part of the directions. After you do that, then classify it by degree and number of terms. So we'll go over that as we go. So let's first put these in standard form. If I combine like terms, this is to the 4th power, this is to the 4th power, so these are like terms. I have 4x to the 4th right here, and I'm taking away 1x to the 4th right there, so I have 3x to the 4th power. All right, from there, we don't have any other like terms, so minus 6x to the 3rd and minus 2. So my standard form part of my instructions is finished. Now we need to classify it by degree and number of terms. Do you know all the classification names? Okay, degree and terms. So let's write this down. If you have to make yourself a flashcard, if you have to make yourself a study guide, this might be the time to do it. Degree. If your degree is a little 0, that means you're dealing with a constant because you probably don't have little 0 written out. If your degree is a little 1, again, you probably don't have it written. That means you're dealing with a linear. It's just plain x. If your degree is a little 2, that is a quadratic. 3 is cubic. 4 is quartic. I know quadratic sounds like a 4, but quadratic we know is when we graph them, we see our parabolas in Algebra 2. So a quadratic is the name we use for the 2nd degree, and quartic for 4th degree. We've elaborated on those names in the past. 5, we're going to say quintic. After that, you just sort of name it for this class. We're just going to call it 6th degree polynomial, 7th degree polynomial, so on and so forth. Okay, that's for the degree. What about the number of terms? Can you name it by number of terms? So let's make a quick note on that. So this is sort of like binomial nomenclature from biology, which we've talked about, that it's like your genus and your species. You have 2 different parts of the name there. So if I only have 1 term, all right, just 1 term, that is a monomial. If you have 2 terms, obviously adding could be adding a negative, so it could be subtracting. If you have 2 terms, that is a binomial. If we have 3 terms being combined with plus or minus signs, okay, that is called a, we're not going too crazy here, trinomial. Okay, after that, you just call it a polynomial of blank terms. Okay, so I'm going to put a little dot, dot, dot. If you want to write that down, polynomial of blank terms, 4 terms, 5 terms, so on and so forth. Okay, well, now look at what we got. I guess I can color coordinate. We're going to classify it by degree and number of terms. So degree, terms, D, T, my initials. So your degree is 4, so I'm going to name this a quartic. And when everything's combined, we have 3 terms, so it's a trinomial. That is all you have to do for these first few examples. Finished. All right. If you want to press pause, try the next two by yourself, go for it. If you already did it and you just want to check, then follow along quickly. So x squared, you should have combined those to be 12x squared minus 2x. That is in standard form. Standard form is done. I'm going to go over here and circle standard form in pink so I know what I'm doing there. Classifying by degree, well, I'm going to underline that in orange. Second degree, so quadratic. And it's two terms, so binomial. Next, you have to expand, okay? This is going to be x squared plus 6x minus 5x, so it's plus x and minus 30. Again, that's x squared plus x minus 30. I'm going to distribute 4x right now. I get 4x squared plus 4x minus 120x. Kidding, I messed up. That's cubed. That's squared. That's first. Okay, so when all is said and done, you should have gotten this expression. Again, I'm using the word expression. It's not an equation. There's no equal sign. You should get that expression as your standard form. And now we are going to classify. So this one's going to be a cubic. And we're going to have trinomial again. All right, all done. Next set of examples. The next set of examples is asking us to implement Desmos. Just because I wanted you to practice it, you really don't need Desmos for all of these, but or maybe you do. I'm not sure. I can't remember. So I'm just going to pull these up on my phone screen so that you guys could follow along using Desmos. So if you go to desmos.com, and let's see if I can focus this a little bit more. I don't want it to be in a glare. I don't know what to do to help. Ooh, all right, that looks like a better spot. Can I move it over? Sorry. Okay, we're gonna do the best we can. So start graphing. If you have the app, even better. I'm gonna go and type this in to this line right here. So x, it's gonna start graphing as we go. Raised to the fourth, then move over a little, plus 2x squared minus 1. Okay, so my graph, let's see what I can do to help you guys see. Ooh, here we go. Sorry, it's so glary. Maybe if I tilt it. No, sorry, I apologize. Okay, so I got this over here. All right, now let's shut down the brightness maybe. That helps a little. Okay, so I have this over here, x to the fourth plus 2x squared minus 1. What does this ask us to do? Find the real solutions. Do you know what real solutions are? Well, if they're real solutions, for starters, they're not imaginary. I know it seems obvious, but sometimes the obvious is really important. Okay, so if they're real, they are not imaginary. When you're setting this equal to 0, you're really asking, when does the graph of the y equals x to the fourth plus 2x squared minus 1, when does that graph intersect the graph of y equals 0? We're essentially solving this system of equations right over there. To solve the system of equations, I didn't have to write y equals in front of this. Could you? Sure, but guess what? Nothing changes. Okay, it's the same graph. This automatically defaults to assuming it's a function. So y equals, now where is y equals 0? If you don't know where y equals 0 is, you have some work to do. Worst case, I guess, if you had to do this, it's so silly, but if you wanted to graph it, there it is, boom. Y equals 0 is the x-axis, so you're really looking for x-intercepts, okay? So if I wanted to find these on Desmos, I'm just going to zoom in, all right? So you zoom in on your phone, pretty easy to do. And the thing I like about Desmos is we can do, if you grab it the right way, horizontal stretches and compressions to get a really nice look at your graph, okay? Then I'm just going to click, and what happens is when it intersects either an axis or another equation, these little points come up that you can click on. And what it does is it gets you your answers. So it says, we're going to solve each equation by graphing on Desmos. Boom. Where necessary, round to the nearest hundredth. So my answers are where these two equations intersect, okay? My real solutions are any answers I can find from this graph where they intersect. I have 2 of them. I'm going to write it in set notation, okay? And they're going to be negative nearest hundredth, so negative 0.65 and positive 0.65. So negative 0.65, comma, positive 0.65. I'm using the set brackets. It's not ordered pair. It's just basically telling you x is equal to that and x is equal to that, okay? I know the brightness is a little funny right now, but I'm just trying to just do as much as I can with the phone and the paper at the same time. All right, the next example, I'm just going to go over here. Oh, I didn't mean to hit enter. I'm going to go over here and I'm going to backspace what I have. That's not backspace, kidding. There we go. And I'm going to put in the other example. So the other example is negative x to the fourth. So let's just stick a negative sign in front. Sometimes you have to look at your calculator. Sometimes it's a negative. Sometimes it's a minus. Make sure you're using the right key. Then this is plus 4x to the third. And last is plus 3. Okay, now my window might not be good. If you hit the home, little house, sorry. If you hit the home, you can go, ooh, I just want to zoom in here. I'm on the graph, so it's like zooming funny, sorry. Okay, so I'm just going to go right there. I'm just looking for that and that. There we go. Okay, here's this little bit of a bend over there. That's that third power happening, and another first power at that spot makes fourth power. But what our answer is going to be, if I just move into a little bit better lighting, what do we see there? We have negative 0.85, make sure you round, and negative 4.05. Okay, so writing out my solutions, moving that over again. Stick this on the side. So what are my real, so you shouldn't be listing any imaginaries, real solutions. Now it's possible that these are non-terminating and non-repeating decimals. If they are, what kind of numbers are they? Do you know? Non-repeating and non-terminating. We can't tell from here because the app is rounding for us. If it's a non-repeating and non-terminating decimal, those are irrational numbers. If they're irrational, it means they're not rational. And if they're not rational, you cannot find them using factoring or rational root theorem. You could either find them for now, where you would use, say, quadratic formula for parts, or we would use a calculator or computer to help us. Okay? Next set. Write a polynomial with rational coefficients so that the p of x, the polynomial function, equal to 0, when we set it equal to 0 and solve, we'll have the given roots. Well, we just saw when we're solving a system, basically finding x-intercepts, you're finding where it crosses that line. And we said y equals 0, that line is, in fact, the x-axis, okay? X-axis. And when we solve a system, solve this, comma, we are going to find x-intercepts. Now, it might not start off that way all the time when we're solving an equation, but as you do the work, you get it equal to 0, you end up solving for x-intercepts for something to get the solutions to maybe a different systems. It's funny how it all works out. So we're over here. They're giving us the roots. If these are the roots, it means x is equal to 2, x is equal to 3, and x is equal to 5. Where did that come from? When you have your roots, you know your ancestry, you're figuring out where it came from. X minus 2, or where you came from. X minus 3, x minus 5. And now it says a polynomial function. In some of the other examples that we've been doing, it'll say equation, so you stick equals 0. It's telling you, yes, when you set it equal to 0, those are the roots, but write the function. And they also said to name the function p of x. So out front, I'm going to follow the instructions. Okay, just do what it asks you to do. It also says with rational coefficients. The phrase rational coefficients or integer coefficients, when they're talking about the integer coefficients or any coefficients, they're really telling you to put it in standard form. Okay, we're reading between the lines. So put it in standard form, please. How do we do that? You do not expand 3 things at once, okay? You are not that good. And if you are that good, well, knock yourself out. But I really don't think majority of Algebra 2 students or pre-calc students are doing that, okay? P of x equals, I'm expanding the first 2. I get x squared and minus 5x plus 6. I still have this x minus 5 next to it. Continue expanding. P of x equals, I'm going to distribute this x to all 3 things. That gives me x to the third minus 5x squared plus 6x. Now I'm distributing the negative 5 minus another 5x squared plus 25x minus 30 equals, final answer, combine any like terms. So we have x to the third minus 10x squared plus 31, x minus 30. So p of x equals x to the third minus 10x squared plus 31x minus 30. Done. This one over here, well, this one ended up being a cubic. I had 3 real roots. I have 1 irrational, and I have 1 complex. Complex because it has an imaginary part to it. This will end up being quartic because, why will it be quartic? Because if you have rad 3 and 2i, you also have negative rad 3, and you have negative 2i, because irrational, and imaginary or complex solutions, roots, come in conjugate pairs. So what do we write? I'm skipping steps. I'm going to have x minus rad 3. I'm going to have x plus rad 3. I'm going to have x minus 2i and an x plus 2i. This will give us those particular roots. Again, we want to call it a function, so out front p of x equals. From there, how does that expand? This one's going to be pretty easy. That's going to be an x squared minus 3. Don't get that? Pause. Pause it right now and go and try it. This one, x squared plus 4. Again, didn't get that? Press pause, please, and go do it on the side and come back. Last step. If I expand all of this, I will get x to the 4th plus x squared minus 12. Any issues you encounter, they're probably a smaller deal than you think. Please press pause and work on it on your own. Okay, find the zeros of each function. State the multiplicity of any multiple zeros. So if you're finding the zeros, it gets its name because you're setting y equal to 0. I'm not going to put it here. I'm going to put it over there. So y equal to 0. Then we use zero product property and solve each one. So x minus 1 is 0. And you set 2x minus 3 to 0. Could you set it with the power equal to 0? Sure. Not necessary. So I get that 1, 0 right there. It's 1. And then over here, I'm going to add 3, divide by 2. Do not be overly confident. The number of people that put 2/3 is astounding. Okay, write it down. Don't be overly confident. Those are my zeros. So let's even label, because you guys don't write down notes on your work, and then you go and look at it, and you don't know how to use work to help you study or to help you figure out how to do something else. Multiplicity. Oops, can't spell. Plicity. The multiplicity here, how many times did that 0 appear? Twice. Okay. How many times did this 0 appear? 3 times. Where do you look for those? At your degree, look at your exponent, whatever you want to call it. That is your multiplicity. If I wrote this out, you'd have 5 factors, 5 bubbles, 5 sets of parentheses. So this one appeared 3 times and 2 times. That is it. Okay. If you don't know what multiplicity is next time you see it, it's because you just watched and you didn't actually try this. Press pause. Do the next 2 on your own, please. Okay? Here, my zeros will end up being, if you need to write it out, I hope you pressed pause and wrote it out. So my zeros are x is equal to 2/3 and my x is equal to -4. The multiplicity of each one, let's abbreviate multiplicity. For this one, 5. For this one, 2. You're done. Next, zeros. X squared is the same as an x plus 0 squared, okay? The 4 is just a vertical stretch of 4. Ooh, sorry, it's a little unfocused. The 4 is just a vertical stretch of 4. Please do not read into that, okay? So what are my zeros? I'm going to write them this time in set notation. There's 0, -2, and -1. Those are my zeros. Multiplicity. Okay. It said for any multiple zeros, 1 time doesn't mean it's multiple. I'm just going to draw an arrow. The multiplicity for that one is 2. The multiplicity for this is 3. You really don't have to write it. It's not multiple. It's just once, so it's 1. Okay? Next set. Please read directions. What does this want you to do? And do you know what that means? Solve. You're finding answers. If you expanded this, you didn't follow directions. That is not what it's asking you to do. All right? Solve. You should have x equals on bottom. Here, we went backwards. It was solved. And then we made the function. Here, they give you the function, And they even gave you a head start on this one and this one, and here they did not. Solve. You have to finish factoring. If you did not do that, again, press pause and go on your own. If I factor this, I get those factors. Zero product property. What do I get? 1, -2, -3. That is it. I'm going to write each answer slightly differently so you could see that more than one way of writing it is acceptable. Next, that's a cube. I know it's a little hard to see on the screen, but you have the paper in front of you, I hope. I'm going to factor. Always, always, always start with the GCF. Look for a greatest common factor. That's how quickly you need to factor, guys, okay? Here, I'm going to write them all out. I get 0, I get 8, and 2. Didn't ask for multiplicity, just said solve the equation, okay? This one, it was a head start already. 40, 10 times 4, that won't help. 5 times 8, that helps. Here. Done. Next one. +3. That makes a -54. Yep. And this time, what are my solutions? They're also going to be my x-intercepts if I graph just the left side. Those are my roots. You should have as many as your degree for most of the cases, unless there's multiplicities or hidden imaginary or complex roots. Here, I'm going to have x. Now, I was going to throw in some fancy notation. Let's not do that. I'm just going to say x is equal to this set. All right, we have, again, 0, -9, and 6. That's it. First page, done. Just a few minutes, okay? Divide using synthetic division. Okay, if I divide these using synthetic division, x plus 2 is what we're dividing by. -2 is the number we use over here. All right, we should remember that. Synthetic division, we just use coefficients. Watch for placeholders. So I have 1, -4, 1, -5. Leaving some space over here, drop the first number. Bottom times box, add them straight down. Bottom times box, add them straight down. Bottom times box, add them straight down. This last number is your remainder. You are not done. Write your answer. This is just shorthand using the coefficients. If you divide, this is your numerator, this is your denominator. Numerator divided by denominator. You could also call this one by their other names. What are their other names? This one is your dividend. Spell check on dividend. Things like that. Divisor.
Hello?
So from there, we're just going to write our final answer. X squared minus 6x plus 13. Remainder. Don't write r equals -31. We're big kids now. Let's do this. Minus 31 over, what were we dividing by? X plus 2. That is your answer. If the directions say divide, your answer is a quotient. Okay? Think about what the directions say. All right, one more. We got one. I'm just going to go a little quicker, a little less of an explanation. Placeholder. So right there. Hopefully I didn't mess up. Now, some people get confused, like, but I thought the remainder had to be 0. The remainder has to be 0 when the thing you're dividing by is a factor. Not everything's a factor of everything else. So you could very well just be finished right now, okay? All right, so I sort of set up number 25 for us already because it kind of takes a long time. So I set it all up. Use the rational root theorem to list all possible rational roots. All my p is my factors of 6. 1, 2, 3, and 6, positive and negative. Q is my factors of the leading term, so 1, negative 1. P over Q, there's my list. Done. List the possible rational roots. These are the possibilities. Then find any actual roots using any method you would like. You really didn't have to use rational root theorem, synthetic division. You could have factored by grouping. I set it up where I already know negative 2 is going to work. 1 doesn't work. Negative 1 doesn't work. So I got it started for us. Negative 2 is going to work. We do our synthetic division. Oh, kidding. That's 0, sorry. 3, negative 6, and 0. See? So that right there, x squared, x to the first, constant. So this is going to be x squared plus 3. If I were to continue factoring, okay, that x plus 2 is because the negative 2 worked. This is the sum of two squares, so that's going to be x plus, if you really want to do this here, I rad 3, and, sorry, I'm squeezing, x minus I radical 3. You don't have to do it that way. You could have set them equal to 0 and kind of solved your own way, but I'm going this way. Then find any actual roots. It doesn't say they have to be real, so I have one real and two imaginary. So x equals negative 2, and then you're going to have positive and negative I square root 3. Done. All right. Here, if I were to list my possible rational roots, okay, my possible rational roots are positive and negative factors of 12 over factors of 1. So really it's just the positive and negative factors of 12. 1, 2, 3, 4, 6, and 12. So that's my list. Done. But it says solve using any method you'd like. Okay, I'm not going to use synthetic this time. Quadratic style. I'm going to factor it. But instead of x and x squared and x squared. 12 is 4 and 3 minus minus. Keep factoring. X minus 2x plus 2. That means I have positive and negative 2 as roots. And then this is x minus rad 3. See, this is a difference. And that one was a sum. That's the difference in, no pun intended, in factoring these. What are my roots? Plus and minus 2, plus and minus, radical 3, and we're done. Roots and roots. Finished. P of 5, or sorry, P of negative 5. You can plug it in. It doesn't say you have to use use synthetic division in the remainder theorem. I'm going to use remainder theorem. So how am I going to get this? Plug in negative 5. I got negative 1, negative 4, 1, and negative 2. And we just go from there. If you just plugged in, remember no calculators on a test or quiz. So just make sure you're working it all out correctly. You should have gotten 18. All right, so my answer is 18 right there. You should have gotten the same. Next, expand each binomial. We're going to use Pascal's triangle. Fourth power, which means we're going to use row 4. These are my coefficients that I start with. X to the 4, 3, 2, 1, none. Backwards, y to the 4, 3, 2, 1, none, and then you're done. So 1, x to the 4, plus 4, x cubed y, plus 6, x squared y squared. If it takes you longer, that's fine. You should have this done if you're watching this video. You should have already done this. And you can just be checking. If you didn't already do this, well, watching me do it, oh, sorry, it's not going to make you know how to do it. So then that's 1 y to the 4th. That would be done. This one's not so bad because my coefficients are just 1. This one, row 3, because of the third power. So third power right here, 1, 3, 3, 1. This one's going to be a little more work. 1, 3x to the 3, 4 to the nothing, plus 3, 3x to the 2, 4 to the 1, plus 3, 3x to the 1, 4 to the 2. There's no plus signs, okay? Don't put plus signs between this stuff. This is all one term. And then last is 1, 4 to the 3rd. It's a little squash there, sorry. Okay, that's my 4th term. Whatever the power is, you'll have one more than that terms. Cube everything. Yes, the x and yes, the 3. They're in parentheses. That's how it works. 27x cubed. Done. 3 squared is 9. Times 3 is 27. Times 4, 108. So 108x squared plus 4 squared is, well, actually, I'll do 9 times 4 is 36 times 4 again, so 144. 4 cubed is 4 times 4 is 1664. All right, done. There it is. Okay, so you should have gotten that. And the last couple of examples, these honestly should be really fast. Okay, they're just some reasoning and some transformations. Determine the cubic function that is obtained from the parent function y equals x cubed after each sequence of transformations. So there's a vertical stretch by a factor of 5 out front. It's reflected across the y-axis. The y-axis is this way. If I reflect it this way, the negative is really on the inside, okay? So I'm going to go right here. It's going to confuse some of you, but we'll deal with that in a second. Horizontal translation, 2 units to the left. So that's going to be x plus 2, and then it's cubed. If you wrote the answer -5, x plus 2 cubed, you're technically correct, because when you cube a negative, it's still negative, so it could come out front. And also when you reflect this graph, x cubed, either left, right, over the y-axis, or up, down, you get the same thing. So it really doesn't make a difference here. A reflection across the x-axis, so that's our normal reflection out front, negative. Horizontal translation, 3 units to the right, so x minus 3 to the right. And a vertical translation, 7 units down, -7. Finished. If you wanted to put a 1 there, you can. How do you use Pascal's triangle when expanding a binomial? Well, we just did it up here. So you look at whatever the degree is. I'm going to put an n. You go to that row. You have to know that the first row is row 0, row 1, row 2, etc., right? Use the coefficients for your first layer from that row, and then you take whatever's here to this power, and you put it to each of the terms. The last term won't get anything. And then you take whatever terms here, start on the right, and do the same in reverse. If it's plus, they're all plus. If it were a minus sign in between, you start off with a positive term, and you alternate positives and negatives. We elaborated on why that is in class. If you still have questions, make sure you ask in class. Can a function with complex roots 5? 5 is not a complex root, so I don't know why that's written. Radical 2 and 3i be a 4th degree polynomial. Can this be a 4th degree polynomial with rational coefficients? No. I already have 3 roots, but if I have radical 2, I also have negative radical 2. And if so that's another one. That's already a 4th root. My 5th root would have to be -3i. I definitely have to have 5 roots, so it can't be a 4th degree. It'd have to be a 5th degree. Okay? If there was a typo, if it was like 5 minus rad 2 though, I don't know if that was a typo, 5 minus rad 2 and 3i, then that's different, okay? You would also have 5 plus 2 rad 2, and you would have -3i. Now you'd have 4 roots, so yes, you'll have 4 factors, and that means 4 x's, that means x to the 4th, then that would be fine, not fine. All right, and that's the end of this review. Hopefully you'll be ready for your test.